everyone, welcome to our channel CodeChef. This is Kusmulata Bhatt, and today we are going to solve the problem Zombie Apocalypse from the CodeChef platform, which is of simple difficulty level and it requires sliding window as prerequisites. So let's understand the problem statement. There are n zombies walking in a line and each zombie is associated with some infection level. Let's denote it as AI. Now this AI value can be in the range of 0 to 9. Here 0 indicates the severe infection and 9 indicates the weakest infection. Now we are also provided with the integer d. This integer d denotes that all these zombies which have infection greater than equal to d can be cured. And also we are provided with another integer k, which are the special antidotes using which we can cure the zombies having infection level less than d. So there are k antidotes. We can use up to k antidotes to cure the zombies which have infection level less than d. Now what our task is, these all zombies are in a line and we have to find the contiguous group of the zombies which we can group, which we can cure. The maximum number of zombies in the contiguous group of this line which we can cure using these k antidotes. So we will be using these k antidotes also and we will be curing all those zombies without any problem which have infection level greater than or equal to D. So we have to tell the maximum possible number of zombies such that we are using these k antidotes optimally. Now what will be the input format for this problem is we are going to contain t number of test cases and then for each test cases we are going to have these three integers n, k and d where n will tell us the total number of zombies, k will tell us the number of antidotes and d will tell us the infection level which can be cured easily. So for the constraint of problem, we have t value lying in the range of 1 and 100, n value lying in the range of 1 and 10,000, k value lying in the range of 0 and 10,000, and we know that the infection level, which is denoted as d integer here, can lie in the range of 0 and 9. So this d is actually the infection level which can be treated. So it will definitely lie in the range of 0 to 9 as the infection level is lying in the range of 0 to 9. So now let's see how we can solve this problem. So in this problem, we know that we are given with n values in which every value is lying in the range of 0 to 9 and we have to select a contiguous range such that all elements in it are having values in the range of 0 to 9 and the number of elements which have value less than d are at most k. So this thing we have to satisfy and we have to select the maximum such range. So how we will be solving this solution? So how we will be solving this question? So one way for this will be brute force one. So what we will be doing is, let's say we have n elements, then we will be starting from a point. Let's say from here we are starting. This is our ith point and then we are moving from here and we are considering how many length we can take from this point such that the numbers which have value less than d here will be at most k. So we will be expanding this up to the point our condition is getting satisfied. Now we will do this for every element present in this array. So what we will be doing is for the ith element, we are going to its index and we are expanding it until our condition remains satisfied. That is the number of elements which have value less than d still remains less than equal to k in number. So this is one of the brute force approach which we will be applying here. But now the time complexity of this solution in the worst case will be O of n square. And we know that our question contains the t value up to 100, and we have n value up to 10,000. Now, in the worst case, we will have our time complexity as O of t n square and t value as 100 and n value as 10,000. So it will increase the 10 to the power 8 operation and it will give us time limit exceeded error. So now how we can solve this problem more efficiently? So what we can use here is we can make use of sliding window technique. So what is our approach will be, we will have two variables, or we can also refer them as pointers here, as start and end. Now start will be pointing to the start of the group we are taking and end is pointing to the index up to which we are considering that from the start we are going to have our group up to the end point. So now we will be keeping our end incremented as long as it is possible. That is, if a of n is greater than equal to d, then we need not to use any antidote and we can simply increment our n. Now, if our a of n is less than d, then what we will be doing? So our step will be to use antidote. So in this case, our k value, if it is not 0, then we can simply use it and we can increment our n as far as we can take again, because we are trying to maximize the number of zombies we have to cure. And if we are not left with any antidote, so what will be our approach is, we will be updating our start up to the point such that our k becomes greater than 0. And if we were not provided with any antidote beforehand, then what will happen? Our start will become greater than n. So in this case, what we will be doing is, we will be simply incrementing our n and we will be getting start and add and as the equal one. So this will handle the case when k will become 0, when k was 0 initially. So what our approach will look like, we will keep our start at 0 index and we will be trying for every n possible up to the n minus 1 index. And if our a of n is less than d, then we will be using antidote. Now, if we are available with the antidotes, then we will be simply using it. Else what we will do is, we will increment our start variable and we will be taking the antidote from the start of the line of the zombie. So what we will be doing is, until the point our start is less than equal to end, that is, we have zombies in our group, we will be getting them from the beginning and we will be taking them in account as long as there is any zombie present in the current group we are taking, and we have k value as 0. If our a of start is less than d, then we have simply got the antidote back, and else we will be incrementing our start, whether we are getting the antidote or we are not getting the antidote. Now we know that our k is going to be greater than, now we know the point that we have an antidote available. So in this case, what we will be doing is, we will be using that antidote again. So this is the case when we will be having any antidote. If k is equal to 0, then this step will not make any sense, because at the end also we will not be using any antidote. So in this case, we will be decrementing our k if it is greater than 0. That is, we have got our antidote back. So we will be using it so as to cure this zombie present at end. So in this case, what we'll be doing is, if our current group is greater than the answer we have found so far, so we will be updating it as n minus start plus 1. and at the end our answer is going to give us the answer for the whole scenario. It will contain the maximum number of contiguous group of the zombies which we can cure. Now the time complexity for this solution is going to be O of n, because we can see here that we are traversing on this array linearly. So this is our time complexity and it will pass a solution under the given constraints. So now let's have a look on the C++ implementation for the code. So here I'm taking the input of t test cases, and then for every test case I'm doing the following steps. So here in the first one, I am taking the input of n, k and d value, where n is the number of zombies, k is the number of antidotes, and d is the value up to which the zombie can be cured without any use of antidote. And then here I have declared a vector for storing the infection level of every zombie. So here I have taken the input of that, and then here I am having the start variable and answer variable, and then for every end value I am updating the and start accordingly. What I'm doing is, if my current element at the end is less than d, then I'm using the antidote if it is available, else I am finding the antidote from the front of my current contiguous group, and I'm taking it from the zombie which is occurring first in that group. So here if my k is greater than 0, then I'm simply incrementing it. Else if we dry run this code, then we can see that decrementing k, in the case we are not finding any antidote, that does not make any difference, because in every case we are then not having anything at the end, and we can just replace it, and while our k is less than equal to 0. So at the end if I am finding the antidote, then I am making it negative. I'm simply taking it to treat this and this zombie which is at end position. And if I'm not finding any antidote, then what will happen is I will not remain with any zombie up to the end point, and I will be starting from the next zombie in the next end. And here I will have my end minus start plus 1 as the 0. So here I'm updating with the current length of subarray possible with the available antidotes. And then at the end I'm simply printing the answer. So now let's run it on the sample input. So yes, it is giving me the correct answer for the given sample input. Now let's submit it and check whether it passes all of the test cases or not. So yes, it is giving me the status of correct answer. So now let's have a look on the Python code. So here again I am taking the input of t test cases, and then for every test case I am taking the input of n, k and d variable, where n is the number of zombies, k is the number of antidotes, and d is the level of the zombie up to which we can treat them without any use of antidote. And then I'm taking the input of the infection level of all zombies from 1 to n, and I'm taking it in zero based indexing here. And then I'm having two variables, start and answer, for storing the start of the current subarray I'm taking in the account, and answer for storing the optimal answer for by taking every end. And then I am looping over the end value, and if the zombie present at my current end value is less than d, then I am using the antidote if it is available, or else I am finding the antidote from the start and taking it from that zombie, and I am updating my start value accordingly. And then at the end I am updating my answer value, and I am printing that answer simply. Now let's run it on the custom input and check whether we are getting the right sample output. So yes, we are getting it right. Now let's submit it and see whether all of the test cases are getting passed or not. So yes, we are getting the status of correct answer. Let's understand some of the common mistakes in this code. So in this code, the major part lies in the implementation of the sliding window technique, that how effectively you can implement this solution without missing any corner cases. So we have to make sure that we are checking every possible case in our code. We are incrementing our start after checking every time. That is, we have to increment our start also for the case when e of start is greater than equal to d. So we have to also start in this case. Like for this case, if we have d value as 0 and we are requiring one antidote as k has become 0 in order to treat this zombie, when we are considering the segment after further, we have to make sure that we are also incrementing the start in this case. If we want antidote of this position, then we have to take our start up to this position by surpassing all these zombies. So the major the major mistakes can be here in handling all of the edge cases in this case, and which can lie on handling the last subarray group. When the answer is our last subarray, we can also mess up of that case. So it will be always optimal to check on these cases that whether we are considering the last group in the case of sliding window. And one thing is here, that if our k is equal to 0, we need not to check for the case when k is less than 0, because we know that we are not going to use any antidote when our k is equal to 0. So we are not going to have the case if we have applied this condition here in which our k is going less than 0. So make sure you are handling all of the cases while implementing the sliding window. Like in this code, I have messed up in the case that I'm incrementing my start only when I am getting back my antidote. But that case will make me fall in a time limit exceeded error, because this loop will get infinite for the case when the first zombie in the group was not using any antidote. So that's it for the video, guys. Thanks for watching.